Hello and welcome. I am Dr. Anil Joshi. Welcomes you to my series Learn Radiology with Dr. Anil Joshi. This is a radio physics lecture and that also in a simplified form. Extensive lectures are available on website or on my YouTube channel. Let's get going to today's topic, that is X-ray dosimetry. This lecture is for radiology residents, so also students of medical imaging technologies. To start with are the disclosures, acknowledgement and disclaimers. Most of the material here what we have used is our departmental material. There are certain illustrations which we have downloaded from net, but we have confirmed that they are royalty free. We acknowledge with thanks all these people from whom we have got all these things, because it is going to be used purely for a educational purpose. Now let's get going towards X-ray dosimetry, today's topic. Now what are the radiation units? These are number of units to measure radiation dose and exposure. First is rad, or radiation absorption dose, short form RAD. It is the amount of radiant energy absorbed in a certain amount of tissues. Second is gray, a unit of absorbed radiation equal to the dose of the 1 joule of the energy absorbed per kilogram of the matter, or 100 rad. The unit is named for the British physician L. Harold Gray, an authority on the use of radiation in the treatment of cancer. Now, after that invented was a milligray, is a smaller unit, a unit of absorbed radiation equal to the 1000 of the gray, that is 0.1 rad. Then is the RAM, or radiation equivalent mean, a unit of measurement that takes into account different biological responses to the different kind of radiation. The radiation quantity measured by the RAM is called equivalent dose. Now milliram, 1000 of the RAM is the unit of measuring of equivalent dose. Second is Roentgen, the international unit of exposure dose for X-ray or gamma ray. Roentgen are named after Professor Wilhelm Roentgen, who invented the X-ray, or the man who discovered the X-ray in 1885. Then is the Sievert. Sievert is a unit for measuring ionizing radiation effective dose, which accounts for relative sensitivity of the different tissues and organs exposed to the radiation. The radiation quality measured by the Sievert is also called effective dose. Now millisievert, 1000 of a sievert, the unit of measuring effective dose, is a smaller unit of sievert. Now unit of measurement, going further on the track, is for determining quantity of radiation exposure or the dose. Now dose is amount of energy absorbed per unit mass at a site of interest. It is of absorbed dose, equivalent dose or effective dose. Now is the exposure measure of the radiation is based on its ability to produce ionization in air under standard conditions of temperature and pressure. Then is the another unit of exposure, that is called as kerma. The quantities of radiation are measured in units. Traditional units which are used since early days of radiation is Roentgen. SI unit, that is the System International Unit, that is SI unit, and modernized version of the traditional metric system. Now this chart gives you SI traditional unit, then coulomb per kg, that is the Roentgen R. Here it is traditional unit Roentgen R, and conversion is given below. This is for the exposure. Exposure is a dosimetric quantity used for ionization radius based on the ability of the radiation to produce ionization in air. Now exposure rate is exposure produced per unit of the time. The SI unit of the exposure rate is the C/kg/second or R/s. In radiation protection, it is usually calculated per hour. Now unit of measurement, continuing kerma, sum of the kinetic energies of all the charged particles liberated by the unchanged ionizing radiation in a simple matter divided by mass of that matter gives you kerma. It has replaced Roentgen, a traditional unit of radiation. Now going further on the track of units of measurement, absorbed dose, measure of the energy absorbed by any type of ionizing radiation per unit mass of any type of matter, is given here that is SI unit, traditional gray, conversion 1 gray we are given to the another unit. Sub names are pracogray or microgray. Now units of measurement containing equivalent dose. Equivalent dose used to compare biological effect of different types of radiation on a tissue or an organ. Particular radiation have high LET and thus more damaging to the tissues than low LET radiation such as X-ray. Relative biological effectiveness of the different types of radiation, that is weighing factor. This gives another calculation. Those who are interested can pause it and have a detailed look. Now units of measurement further containing effective dose. Effective dose is a calculation that considers the relative biological effectiveness of different tissues exposed in terms of risk for cancer or heritable effect. It is used to estimate the risk in human, that is one region of the body or the another. The comparative radiosensitivity of different tissues are different. Now this is the detail. Organs versus the tissue weight on which we calculate a maximum permissible dose or the radiation dose. It is essential. Now units of measurement containing the measurement of radioactivity. Now we are going to A. Describe the decay rate of the sample of radioactive material. Here it is given a traditional unit is curie and conversion factor is given below. Now here we are given different type of units of measurements which takes into consideration exposure, absorbed dose, equivalent dose, effective dose and radioactivity. They are Coulomb, Gray, Sievert and Becquerel. Traditional units were Röntgen, Rad, Rame or Curie. With that, we are coming to end of a small topic of radiation measurement. I thank you for giving me your valuable time. Please visit our website for comprehensive and detailed lecture on this topic and also many more. Till then, thank you. Goodbye. Take care.